One problem with the page table is this. See, not to run any process, at least the part of the process which we want to run should be in the main memory, and at any time the page table corresponding to that process should always be in the main memory. Okay, so then it is going to introduce some problems. One problem is the page table itself might not be small enough to fit in a page. See, okay, instead of talking about it, I'll take an example and explain you, that will be better. So let us say, one example is, let's say logical address space is 22, logical address is 22 bits. So what does it mean? If it is byte addressable, then logical address space equal to 2 power 22 bytes. Okay, and assume that page size is 4 KB, right? Then what is the page offset? Then page offset is nothing but 12 bits. 4 KB is 2 power 12 bytes, and assuming that it is byte addressable, page offset is going to be 12 bits, right? Now logical address is to 22 bits and page offset is 12 bits. Then how many pages are there? Then in order to put the page number field will be equal to logical address minus page offset, if you remember it. Then 22 minus 12, which is nothing but 10, isn't it? Now what is the number of pages then? Number of pages in this particular process is going to be 2 power 10, which is 1k pages, right? And if you assume that page table entry size is 4 bytes, right? Then what is the page table size? Page table size is number of pages into size of each page table entry, so which is 1k pages into 4 bytes, which is nothing but 4k bytes. This is its page table size, right? Now if you observe this, so what is the meaning of this entire question is, watch it. So I'm saying that the process size is 2 power 22, that is logical address space, and now the main memory size is I didn't say anything about main memory size, but then what we know is the size of each frame or the size of each page is 4 KB, right? Then what we do is we can split the process into many pages in such a way that each page can comment it in one frame happily, right? Without any problem there. Now at any time, in order to run this process, the part of the process which we are running should always be in the main memory, only the part of the process. Either it could be 1 page, 2 page or 4 pages. That is called working set. Working set is the number of pages that the process will try to refer at any point of time. At any point of time, what happens is there is principle of locality. I'll again talk about it later anyway. Principle of locality says that at any point of time, a process will try to refer only a few number of pages, and those pages is called as working set. So in order to run this process, you need not put all the pages in the main memory. You can put the chosen number of pages in the main memory according to your requirement. In case if you need more pages, later there will be a page fault and you can load that page later, right? But anyway, if you want to run this process, always the page table should be in the main memory, right? And already main memory is divided into frames, and therefore your page table should also be divided into pages in case if it is too big to fit in one frame. Are you following this? So okay, see this. Now this is the process, right? And these contain these many pages. Therefore for this process there will be a page table, isn't it? And now this page table will contain the number of pages in the page table will be equal to number of pages in the process, and each page table entry is 4 byte anyway, right? Therefore this entire page table has to be again kept in the main memory, right? Anything that goes into the main memory has to go in as pages because it is divided into frames, right? Therefore it is your responsibility to see that even this page table either fits in one frame or in case if it is too large to fit in one frame, you are supposed to divide into pages and again put it there. Getting this? Okay, now watch this example. So in this example, what happened is we got the page table size as 4 KB. We are lucky here, isn't it? Why are we lucky? Because finally the page table size happened to be 4 KB and the frame size is also 4 KB. So without any problem, this entire page table can fit in one frame, any frame, right? Let us say this entire page table is loaded in this frame, right? Then what happens is the CPU will be provided with the base address of the page table. This is called base address of page table. Now this points to the starting address of the page table. If the page table is loaded in this frame, then this will contain the frame address of that. Got it? Now whenever CPU generates any logical address, that logical address can be divided into two parts. One is page number and other is page offset. Now we can go into the page table beginning using this base, and then we can take the page number and then get into that particular page, right? And then using that page we can take out the frame number, and once we take out the frame number, right, and then we can take out the page offset and then make it as the physical address and again get into the main memory. That is what is the concept. In this example, we are just lucky that the page table is going to fit in one frame, but then we are not always going to be that lucky. Now I'll show you one example, or in fact we have seen many examples in which if the page size is 4 KB, our page table size happened to be very much bigger than 4 KB, then we didn't deal with this. Actually we should deal with it always, but there I didn't want to show you and confuse you. Now let's try to deal with this. I'll take a different example and I'll show you everything what is happening here. Okay.